The pH is the negative log of the hydrogen ion concentration. That sounds complicated, but what that means is we have a number, which is the pH, equals the opposite of the logarithm of the concentration of hydrogen atoms. And we're given either this number and asked to find the pH, or given the pH and asked to find the concentration of hydrogen ions. The lower the pH, the higher the acidity. That means the concentration of hydrogen ions is greater. The higher the pH number, the higher the basicity, or the baseness of the solution. Let's do a problem. For an aqueous solution, if the concentration of hydrogen ions is 5.0 times 10 to the negative fourth, we want to find the pH. We know that the pH is negative log of the concentration, so the pH in this case is going to equal negative log. Notice there's no base here of the logarithm. That means that this is base 10. We can just plug it right into our calculator. 5.0 times 10 to the negative fourth. I'm just going to enter this in my calculator, and I found that the pH is 3.3010299. Let's just do 2 decimal places, so I'd say the pH is 3.30. So this is a pretty acidic concentration. Let's do another problem. If the pH of a solution is 9.70, what is the concentration? I'm using the same formula, and we're just given pH instead of the concentration this time. So 9.7 equals negative log base 10 of H. To solve this, we first want to isolate the logarithm. It's not totally isolated because it's negative right now. Multiply both sides by negative 1. Get negative 9.7 equals the logarithm. To solve logarithms, what we usually do is just convert it into exponential form. Since the base of common log is 10, that means we have 10 to the negative 9.7 power equals the concentration. This is something I can just plug into my calculator. And what I got was 1.99526, and then my calculator displays E negative 10. Let's round this to 4 decimal places, so I'm going to leave it as 1.9953, and then I'm going to write it as 10 to the negative 10th. Most of the problems in the homework will either accept scientific notation, which is what this is, or decimal notation, standard notation. To write this in standard notation, which I don't really recommend since it's times to the negative 10th power, you could write 0.123456789 zeros, and then 19953. Like I said, scientific notation is probably a little better. Thank you.